Okay, since we don't have much to cover on Thursday, so let's learn something about Java. So let's talk about the Java bytecodes, even that's option. That's optional section. So Java bytecode. Not sure how many of you already took the Java class, but have you ever heard about Java is platform independent? So that means when you have a Java source file, so then after you compile, then you just need to deliver your bytecode file. They should be able to run in different operating systems. So that's different from C++, because for C++, even you have your source file, then you run your compile in the Windows. So then you try to move your execution file to Unix or Linux or Mac system. They cannot run because they are platform dependent. But Java is not. Java actually, for all the Java source file, they are the .java Java file. This one is the source file. So each source file, they will compile into a Java bytecode file. So what is the Java bytecode? Java bytecode, that means class file. So you see, actually in C++, all the .cpp file, after they compile, they will become a .obj file. So then they need to, through the linker, become an execution file. But Java is different. Java, you have a source file. So when they compile, they become a Java bytecode file. Supposedly this class file, they should be able to run if you compile this source file in Windows system. So then you move this class file to Mac system. They can be run correctly. The reason is this class file kind of only have all the instruction and the machine language in here. The important thing is how to translate those machine code on different operating system is you need to install the specific JVM file in different operating system. So each operating system, for example, in Windows, if you want to run any Java file, you need to have your JVM window version to install on your window version. So we use this one kind of the translator or dictionary. I can translate this class into the machine code, machine language my Windows system understand. So the other thing, when I want to run on the Mac system, I need to have another JVM, another translator. So this translator can translate this class file into the machine code for the Mac system to understand. So that's mean Java bytecode file. So that's why Java after at late 1990 so popular. Not only the GUI, the most important thing is they are platform independent. So and also here is they in the Java bytecode file, they are stack-oriented instruction format. They all put each method in an individual memory stack. So then you have operand in the stack. You have operand stack. You have instruction stack. You have your operator stack. So each instruction for your machine code, of course, they are 1 byte. Because remember your machine code only 1, 2, 3, 4, 5. So 1 byte unsigned actually already can be, you can have 512. 255. So that's can kind of you have a lot of instructions, so that 1 byte is enough. But for the operand stack, they are each one is 4 bytes. So just like earlier I said, in C++ we call function. In assembly language, we call procedure. In Java, we call method. The reason is method doesn't need to have any prototype, and method belong to a class. So each method actually there is on stack frame. The stack frame is still similar as we show you in assembly language or C++. You see the stack frame. They have local variable. They have the operand you need. Okay, so that's you see the return address parameter list. They are all the same. So Java typically is pure object-oriented concept. So they only have the primitive data type is when they have their character, their car actually is 2 bytes because they do the Unicode character. So then, but they do have byte alone. So that's 1 byte. You have short, int, long, float, and double. So that's the data type. Since we talk about Java bytecode for the sampling example, so they do have the compare operator. So by their compare, you see the comp, you have fcomp or dcomp. So they just according to you compare floating value or compare the double value. So the same thing later when we try to retrieve the data, they will according to their floating number or their integer type. Okay, so to help you to understand, we just give you a couple examples. For example, that's the add to example. We do that many times in C++ or our add to this week. You see you have A equal to 3, B equal to 2, sum equal to 0. So we want to assign A plus B equal to sum. So of course, this one is in your source file. But after your source file compile become the dot class file, they will become the assembling language. Okay, so then the assemble of Java bytecode become like this. You can see here the same thing. Remember our listing file. We show you the memory occupation. So you see here, start from 0, 1 byte, 2 byte, 3 byte. So each one actually is 1 byte. So this one, you see here, A equal to 3. 3 is a constant number. So then we need to have a constant integer number 3. So then the next instruction, we will store the integer number into the one integer variable. That's it. We call that variable is 0. So they have a location index. That's the location. So then again, I have constant number 2. I need to store that in B. So B actually is another location index. So they each variable name, they have their location index. So then constant 0 for sum. So you see sum is number 2. So after we have these 3 values, they all have their value, right? So we load the value from the index 0 and the load value from index I. So then I perform addition. So then I store the addition result into the 2. So that's the sum. So you can see here, like earlier we say, they are the operand stack format. You see, you have your operand stack. So each value they do 1 by 1. So then when they have any operation, you just need to pop to operand from the stack. So after you're done, you just push back your value. So that's one example for the integer. So the same thing, how about become double number? So we still have A, B, and sum, these 3 variables, right? So then here, they will become location index become bigger because earlier is integer. So they kind of only give them 1. So then the location for the double, they become double. So then here, you see, originally you have 3.1. So that's why 3.1, actually, that's the same thing, the constant number. But actually, I don't know why they say the pound sign 20. But we only can guess this one is just a double number. So occupy 2 space. So then you have your, actually occupy 3 space because here you see 3. So then you store that this value into the location 0. So this one just instruction, so they only have 1 byte. So then the next one, you have another instruction. So then they have 2. Even that's 2, but you are double, so we have bigger space. So we store this value into the index 2. So then after you load 0, 2, then you add together. So because you see they are all the D decimal, they are the double value. So then they add together. Yeah, so the last one is the same thing. We assign the value. We have the Boolean result. Then you see we have if statement. So then we compare the result. So the same thing you see here, you only have 2 variable defined. So that's why they have their location index. So the first one is double. So the second one is result. So then after you have your values saved in the double and the result, that's the finish until here. So then we need to compare A. So that's why we need to load the 0 value. So then you have the 2.0 is constant number. So that's why they compare to the constant number. So you see they do the D compare. Okay, so if less than, they do something, they will go somewhere. So there, if less than, they kind of like, if this condition is true, you just go to somewhere. So they go to the 19. Okay, so that's the 19, they return true or false. Otherwise, you go to the 21. So we know the first one is 19, they just mean true. So then your result, otherwise, you see they will continue, go 14. So then after you have your constant number, so just do the store your value result. Yeah, so yeah, the Java bytecode actually is optional. But one thing is, since we have extra time, so I just want you to introduce you to see how the Java bytecode actually they look like. Otherwise, usually we just write the Java source file we run, then we know JVM translate that, but what they translate. So here you are, that's the JVM, how they translate to make them have match into their operating system machine code.